Welcome to this explainer. Let's get right into it. Today, we're mapping out the absolute ultimate embedded systems roadmap for 2026. If you're a focused learner, someone really wanting to become an industry-ready embedded systems engineer, you're in exactly the right place. We're going to take a super structured, step-by-step look at how to go from a total beginner to a highly sought-after expert in this incredibly exciting field. Okay, let's dive into this. Why do we even need a roadmap? Well, the biggest problem I see beginners face is just getting completely overwhelmed. They try to learn programming, then some electronics, maybe a little IoT, but it's all separate. They're grabbing random technologies without any logical plan. And the result? They end up totally confused about how everything actually connects in real-world product development. When you compare unstructured learning to a structured path, the contrast is honestly night and day. Random learning, it just leads to massive information overload. You miss the foundational basics, you struggle to build real projects, and you're left completely unprepared for technical interviews. But with a structured roadmap, you're learning technologies in the correct sequence. You build practical skills layer by layer, and that means you become job ready much faster, because you actually understand what the industry needs right now. And the reward for following this structured path? It's massive. Seriously. By 2026, senior leads or architect embedded engineers with 10 or more years of experience in India can make upwards of 40+ lakhs per annum. No joke. That is an incredible earning potential for folks who truly master these skills. This highly lucrative career path scales rapidly too. To put it in perspective, freshers usually start out earning between 3.5 to 6.5 lakhs. But as you transition into mid-level and senior roles, say crossing that 6-year mark, your value absolutely skyrockets to between 12 and 22 lakhs, all the way up to that 40+ bracket for technical architects. The financial trajectory here is just incredibly rewarding. So what's driving all this massive demand? Well, think about it. Almost every smart device on the planet needs an embedded system. We're talking everything from the complex battery management in an electric vehicle to the precision robotic arms used in smart manufacturing. Booming industries like IoT expansion, robotics, and medical electronics are basically desperately hunting for talent right now. And with AI-powered edge devices and 5G applications hitting the mainstream, this growth is just exploding even further. To get you ready for those exact roles, we've taken this massive 14-step roadmap and chunked it down into 4 logical phases: building the core foundation, mastering hardware and protocols, advanced tech and specializations, and finally, launching your embedded career. Phase 1 is building the core foundation, the bedrock of embedded systems. You literally cannot skip these fundamental building blocks. Step 1 is C programming. Embedded C is absolutely non-negotiable for direct hardware access. It teaches you variables, pointers, and memory management. Next up, step 2 is electronics fundamentals. You need to grasp concepts like Ohm's law and MOSFETs so you can actually read circuit diagrams. And finally, step 3 is digital electronics. Getting comfortable with logic gates and flip-flops helps you understand processor design right at its very core. Moving right along to phase 2, mastering hardware and protocols, which is all about making devices communicate. This is where we take that foundational knowledge and start making our physical devices actually interact with the world. Think of this phase like framing a house. Step 4 introduces microcontrollers, dealing with things like timers and analog to digital converters, which, by the way, are what let our digital brains read analog real-world data. Step 5 tackles communication protocols for device networking. And step 6 is huge, mastering ARM architecture, specifically the Cortex-M family, memory maps, and the boot process. This is the absolute industry standard for modern, high-performance embedded products. So the crucial point is, how do all these pieces actually talk to each other? Well, communication protocols act as the vital languages between your hardware components. You use UART for basic serial debugging or connecting GPS and Bluetooth. SBI is your go-to for high-speed connections. Think flash memory, displays, and fast sensors. I2C is absolutely perfect for things like temperature sensors, EEPROM, and RTC modules. And then there's CAN. The CAN protocol is 100% essential if you ever want to work in automotive electronics or electric vehicles. Now, when it comes to the microcontrollers themselves, there is a massive variety out there. You've got your legacy chips like the 8051 or AVR, but let's be real, modern development heavily leans on STM32, ESP32, and ARM Cortex-M. Though, if you're a beginner, starting with an Arduino or an STM32 is definitely the way to go because of the incredible community support and rock-solid documentation. Next up is Phase 3, Advanced Tech and Specializations, Becoming Industry Ready. Let's move to this next level and see how this builds your capability to create really feature-rich, scalable applications. This is exactly what separates the beginners from the highly sought-after senior engineers. Step 7 takes you deep into embedded Linux, using tools like Buildroot and Yocto to build custom operating systems. Step 8 involves device driver development. This means writing the actual kernel modules and sysfs interactions that let your Linux OS talk directly to the hardware. And step 9 is all about mastering real-time operating systems. Just to be super clear on why RTOS is so critical, modern products have to perform multiple tasks at the exact same time, and RTOS manages these tasks efficiently while meeting incredibly strict timing requirements. In advanced embedded systems, if you miss a deadline by just a single millisecond, it could cause a complete system failure. So yeah, RTOS knowledge, like understanding context switching and semaphores, absolutely non-negotiable. Rounding out our advanced steps, we have debugging and Git version control, which you literally can't survive without in a professional team. Then we look at some incredible future scopes: IoT development using MQTT for cloud messaging, automotive systems relying on strict AUTOSAR standards, and, my favorite, combining hardware with AI using Edge AI and TinyML. We're talking predictive maintenance and autonomous driving stuff here. It is so cool. But remember, an engineer is only ever as good as their tools. You need to get deeply familiar with IDEs like STM32CubeIDE and, honestly, more importantly, hardware debugging tools. Mastering debuggers like ST-Link and using oscilloscopes and logic analyzers to actually visualize your electrical signals, that will save you countless hours of frustration down the line. And, of course, being a pro at Git and GitHub is a total must. So how do you actually prove to recruiters that you know all this? Through projects. You don't just jump right into building self-driving cars, right? You start simple. A digital stopwatch, an LED blink. Then you move up to intermediate systems, like maybe a smart irrigation setup. Eventually, you're building advanced stuff like EV battery monitoring, a CAN bus system, or even AI object detection. Building real-time projects is, without a doubt, the absolute best way to prove your practical implementation skills. Finally, we arrive at phase 4, launching your embedded career. This is all about preparation and avoiding those early pitfalls. I have to give you a helpful warning here, because these common beginner traps will completely derail your otherwise perfect roadmap. Do not try to learn multiple programming languages at the same time. Please don't skip your basic C fundamentals or your electronics basics. If you just memorize code instead of actually understanding the underlying logic, or if you ignore Git and avoid practicing debugging, you are going to seriously struggle to land a role. And this brilliantly illustrates how your targeted learning maps directly to specialized, highly lucrative roles. If you love C, ARM, and RTOS, you should aim for firmware development. If you prefer getting your hands dirty with kernels and drivers, you become an embedded Linux engineer. If vehicle electronics thrill you, automotive embedded engineering is your path. And if you're fascinated by making smart devices even smarter, Edge AI engineering using TinyML is definitely calling your name. Here is your ultimate execution plan for actually landing that job. You need to build, let's say, 5 to 10 real-time projects and maintain a highly active GitHub portfolio. Practice your C programming every single day. And here is a fantastic insider tip. Genuinely learn how to read and interpret hardware data sheets. Hiring managers actively look for developers who can do this. Beyond that, get out there, attend hackathons, network on LinkedIn, and show off those practical skills. Now, our source material highlights platforms like Embedded Hash as a great option for folks looking for structured mentorship. They basically provide industry-focused training that perfectly aligns with this exact roadmap we've just covered. Everything from embedded C and ARM to RTOS, Linux, IoT, and Edge AI. They really emphasize practical learning with actual physical hardware. Plus, they pair you with experienced industry mentors who guide your career, making sure you are totally job-ready through rigorous interview prep and resume building. So, it's time to take action. Stop getting overwhelmed by disconnected, random tutorials and start following a path that actually leads to a high-paying career. The roadmap is clear, whether you leverage a training platform like Embedded Hash or tackle it completely solo. The path to becoming a job-ready embedded systems engineer in 2026 is right in front of you. The only question left is, are you ready to stop learning randomly and take that crucial first step?